Hello, good afternoon. My name is Harsh Gupta. I am from BTech 4th year, Mechanical Engineering. I welcome you all to this technical session 12. First of all, I would like to call Dr. Jitendra Kumar Tivyar, SRM, on the dice for, and I would also like to call Dr. Mandeep Mittal and Dr. Ravindra Kanodia sir on the dice. First and foremost, sorry, Dr. Jitendra Kumar Tivyar, SRM, Institute of Technology, Assistant Professor, Department of Mechanical Engineering. He he is presently working as a research assistant professor in Department of Mechanical Engineering, SRM, Institute of Science and Technology, Chennai, India. His research interest includes modern manufacturing technologies, tribology of carbon materials, polymer, polymer composites, self-lubricating polymers, lubricating tribology, and, and coating for advanced technologies. He obtained his bachelor's degree from UPTU Lucknow in honors in 2007. He obtained his master's from Indian Institute of Technology, Kanpur in 2010 and PhD from the same institute in 2017. I would like to call Dr. Ravindra Kanodia to facilitate our keynote speaker with the sapling. Now, I would like to call Dr. Jitendra to address the gathering and start with this lecture.
Your name is
Harsh Gupta, sir.
Okay. Yeah, very warm good afternoon to all of you, and thank you. Very nice introduction read by Mr. Hers. Myself, Jitin Katiyar from SRM Institute of Science and Technology, Chennai, Katankulathur campus. So, this work I am going to present for which carried out by my one bachelor student and PhD student both, and that bachelor student right now is doing MS in Australia, Monash University. So he did also a very excellent research work in that polymer composite material. So basically I am going to present today that effect or influence of nanofillers and how we can choose the nanofillers to enhance the properties of polymer composite, because polymer is less thermal stability. That is the biggest issue in the polymer. Also mechanical properties of the polymer is not that much as metals or other materials is having. So how we can use that mixer of the polymer composite material to enhance the property of MEMS, that is called a micro electromechanical systems. These are micro or nano devices. That means like any one dimensions, either height, width or length in a micron range or nano range as per that definition. And these are very sensitive devices, like in steering we are using that due to the impact in our car, the airbags open. So very small chip we are using that sense that much impact. So one time only. So how we can ensure that the life of those highly precise component and we can say that cost is also very involving in manufacturing of those precise component. How we can enhance, that is the only topic, and it is a lot of scope. You can also perform your research work or your BTech project so that you can get a very good job in bearing industries, NVC or RANE, whatever it is there. So it is a very good field. Everywhere it is a very demanding field in this area. So my outline of my presentation, I just give you the brief introduction about travelology because that is very important everywhere. Whenever you are walking on the road, then also because of the friction, you can walk over the road, and also everywhere in friction, textile, it is a friction. You are wearing the shoes, there also the wearing problem happens. So how we can reduce that particular wear or enhance the life, like woodland shoes, one time you purchase and it will not wear, because what happened, they are using the polymer soles, and now they are using the polymer matrix, they add some fillers. So enhancement of the life, we want friction also to walk over the road, and but we don't want to wear fast. So then only everyone can purchase. So every industries are investing huge money in that aspect. Either Adidas, Reebok, $1 million research on this travelological aspect. Intel, IBM, whatever you are purchasing, laptop or hard disk or mobile phones, due to the frictional heat only, if frictional heat is more than your hard disk will crash. So it means that your lubrication, whatever the coating provided over the hard disk, that is a silicon disk, that completely eliminate and your system gone. So that's why this travelology is everywhere. Wherever you want to apply, you just think of which area you want to work. That is very important. So we just show our two part, our results, this travomechanical issues in MEMS and their solution, and how we can improve the wearing life without adding any lubrication. That is the main thing. So travelology is nothing but when two bodies are interacting each other. Then what happens when two relative motion is there in between the body at interface, friction will occur. So due to that friction, frictional heat occurs, and that causes the wear. And how we can reduce this friction in wear, then we can add the lubrication. So it is known as the study of effect to reduce the friction and wear by addition of lubrication. This lubrication either in the form of liquid, in the form of solid lubricant, or in the form of semi-solid lubricant such as grease. So that lubricant is very important at the interface wherever the relative motion is there. So it is very important in terms of safety, in terms of efficiency, in terms of reliability of component, and it is all department. Either you are in material science, you are in biotechnology, you are in civil engineering, or you are in automotive engineering, mechatronics, or any department. So it is kind of an interdisciplinary field where you can work to enhance the reliability of the component, efficiency of the component, and also sometimes safety, because in car we require the safety. That is very important. And also our component, whatever we are using, that at least must be a longer life, because if you are using the brake material and it will fail very early, then it is too cost in the car. So at least life of the brake material should be high. So that is called a friction material. That research on the RANE brake or Brakes India, they are spending lot of the money to make the polymer composite or some polymeric composite develop, which gives you the better wear life of your brake shoe. Everywhere we are using. So in terms of economic impact, if we can talk about, it is huge. It can in any country, it can add 1/3 to 1/2 of their GDP. If GDP is 5 percent or something, whatever the GDP, that add at least 50%. In industries also, most of the material, most of the machineries are failed due to the corrosion, due to the friction and wear, and due to the material degradation. So these are the report which presented in 2015 approx that material loss in any country, that is a US report, that is a cost of around $100 billion, and wear due to the wear component failure approx $100 billion. So if you can save at least 2% or 3% of $500 billion, then you can add at least one third to half of that particular country's GDP. So that is very important field, and it is very simple to understand, and it is very easy to apply everywhere. So friction is not a new term. Travelology only developed that 1961, the Jost report came, then only they just friction, wear and lubrication, they just say the new term, introduce the travelology. But friction is long back. So we are studying the three principle of the friction, three laws of the friction. But unfortunately, those laws is only occur in the macro scale, not true for your micro or nano scale. When we are getting the smaller or size, then the van der Waals forces is more predominant than other forces. Surface roughness plays a very important role in that small scale. So that's why the travelological issues are very high in a small scale. Because nowadays everything is very miniaturized. Either you can see hard disk also very compact, very light. And the life is also, we want more because we save our data. So how we can enhance that particular coating or some other material, so that is very important. So friction generally gives by the Leonardo da Vinci, and they just he just make a sketch. These are the three sketch, which was further prescribed by the Ammentons, so that you can know by the Ammentons law. But Ammentons only see those pictures and then write according to these pictures, nothing else. They have not established, but Leonardo da Vinci was the first person who make such kinds of the sketch. So from this first sketch, friction is directly proportional to the normal reaction. In this, Ammenton's second law gives that friction is independent of the surface area. That is macro scale, but that law is nowadays it is not true, because that is not a tells about what type of the area, either that is apparent area or real contact of area, because every material is having own asperities, own surface roughness, because no surface is perfectly smooth, either material or ceramic. So that's why it is nowadays it is changing, that is a real contact of area. So these type of the statues, people can move from one place to another place, and here beauty, you can see that they are using, they know at that time of Egyptian age, they knows how to reduce the friction, and we can move that big statues from one place to another place. So you can see here these wooden blocks, because they know that static friction or sliding friction is more, rolling friction is less. So they use the wooden cylindrical block to move the statues from one place to another place. And this person here, you can see the pour some water or lubricant to reduce the further interfacial friction, so that easily you can move that. So Mesopotamia or that such kind of the statues, that time they did by this, reducing the friction between the interface. So it is not a very till now no such experiment so developed till now. We can say that the friction is that much for that material. we can't quantify that friction for same material, because as I tell you that here you can see the surface is always having the asperities, and maybe all asperities are not in contact, maybe one or two in that particular surface that are contact. That's why when either you can place your surface like this or like this, your friction is never changed. And that is the simple example. When you rub your palm, then due to the frictional heat it warms. So that lecture in 1963 Richard Feynman lecture, that was the famous lecture presented by this Richard Feynman, and he tells that it is not quite well understood in that till now the era, the friction. And another point, what is the wear? We are material loss, just a material loss. Due to that material loss, that is known as a wear. So material loss is anywhere. These are the gear trains. Here you can see that due to the run time, you can see the cavities forms and pitting forms. Such type of the failure happens in the gear train, and then you can replace the gear. That costs a lot. So different types of the wear: abrasion wear, adhesion wear, surface fatigue, like due to the cyclic loading on the material, that surface or subsurface crack propagates and it fails after some times. So erosion is also one problem. Hydro turbines, whatever hydropower plants we are using in India or any abroad, turbines are failed due to the silt. That is due to the erosion. So that is the basic understand. You can understood that what is the erosion and corrosion. Erosion is a chemical formula, and corrosion is a physical phenomena that occurs in that things. So further, when we are adding the lubricant to enhance the life, the function of the lubricant to remove the heat by increasing the thermal conductivity, remove the contamination, remove the debris from the surface, so that your material will not fail. So there are 4 types of the regimes. It described by the Strybeck in 1942. That was the German scientist. So in Strybeck, they define the 4 regimes, like when there are asperities contact and very thin film is in between the 2 matting surfaces. So they are telling that that is known as a boundary layer lubrication. So that boundary layer lubrication occurs in the clutch, bearings. So there are very thin film occurs. And displaced boundary means your load is very high, and means asperities are compressed. So that is called a displaced boundary layer. Hydrodynamic means that occurs in the turbines which are runs at a very high speed and high load. Then both surfaces are very far away. That is called a hydrodynamic. But due to the elastic nature of the material, it can compress some fluid. Then it is known as a elastohydrodynamic lubrication. So when we work on this boundary lubrication, you can see the friction is always higher. But when we slowly move to that mixed lubrication or hydrodynamic lubrication, then it reduces, and further it can increase in that particular range. So practical objective of tribology, it is very important to understand that where we want to work. According to that, we can select the material. Either sometimes we need the minimum friction, minimum wear, like bearings, cams, gears, automobile engines, critical component. So there we require the minimum wear and minimum friction. Then we can develop some coatings, either coatings through thermal spray coating or polymer coating to reduce the friction and increase the life. And sometimes we require the maximum friction and minimum wear. That maximum is not that much, that is the optimum friction, but it should be at least 0.4 to 0.5 in that range. Like brakes, we require the friction, then only your vehicle can stop. But we require that brakes will not burn out fast, it can go longer. then only fruitful. So in that case, minimum wear is required. So we can develop the material in such a way that it can gives the longer life with optimum friction. And sometimes we require the maximum wear and maximum friction. Example is eraser. So whatever you have written on the paper through pencil, it should be completely erased. Then we require the maximum wear so that you can wash off, and maximum friction also. Then only it can erase completely from your paper. Sometimes it requires the minimum friction, maximum wear, like when you write from the pencil, then it can means when you write, then you required for writing less friction, then only you can write over the paper, but your pencil lead should be wear, otherwise you can't write anything. So these are the different area, what area you want to work and what is your objective. According to that, you can select the material and then select the proper parameter in that particular tribological field. So now we just move to our what are the issues in the micro electromechanical systems. So you can see this type of the comp structure that is very sensitive to operate your steering bag, airbags in that particular one. So here you can see that here you can see that very small gears, and that enhance, then these gears can rotate due to the motion between these gears train, these comb structure is moving. So due to the movement, what happened, very few life cycle it can worn out, and the cost of fabrication is huge for such type of the component. So that is the problem in the MEMS component. So nowadays we are using the material for fabrication of MEMS is silicon, quartz, piezoelectric crystals, and polymer also. So polymer is like PMMA. There are two kinds of the polymer, positive photoresist polymer or negative photoresist polymer. This negative photoresist polymer SU8 that is patented in 1982 by IBM. And after development of this positive negative photoresist SU8, that was the biggest invention by the IBM, and then nowadays it is widely used to fabricate the MEMS component SU8. So SU8 is the newly invented, and it was patented in 1985 by IBM. 1982 they developed. So in mostly IBM component they are using the polymer SU8. SU8 nothing but it is a 8 epoxy group bisphenol A glycidyl ether. Okay, that is kind of epoxy. So what are the advantage of this SU8 over other polymer material? So SU8 can sustain up to 330 degrees centigrade, like other polymer only 110 or 120. It is a biocompatible material, so you can also coat in your knee or hip joints also. It is having the good optical properties. So in electrical also we can use it. Very easily you can fabricate within a 60 seconds of UV light exposure. You can solidify SU8 immediately, but it requires the UV rays. So means in sun also, there UV is there, then in that sun also it can solidify easily. So that's why it is very cost effective, and within a 1 gram or 2 gram of SU8 you can fabricate the 3D structure. That is the beauty. But in silicon, what happened? That was very brittle material. When you cut it, then immediately your structure can be break. So very sensitive tools or very precise tools we are required to develop the structure from the silicon. So that's why SU8 is a good replacement of the silicon. That was the ideal semiconductor material. Only disadvantage of this SU8 is it is having the poor tribological properties and poor mechanical properties. These are the only disadvantages. If we can improve these disadvantages, that material is very good in fabrication of MEMS component. So in this work what we did it, That was my doctoral work. This work I did it in my doctorate in IIT Kanpur. So I added graphite and talc. Firstly, I added all carbon fillers. Then I found that graphite is a good, either graphene or multi-wall CNT. Then in literature, I found that this talcum powder, whatever you are using in your face, the base talc, without adding any chemical, that was also very good solid lubricant. So I thought that because talc is having the OH group, so it is very easily makes the bond. So I just thought that to mix the graphite with talc in a same proportion, 5-8% means 2.58% talc, 2.58% uh, graphite. So it is very good bonding happens because of the OH group present in the talc. And also found that it is a very good for this research, and without adding any lubricant, our friction from SU8 is having 0.6 to 0.7 coefficient of friction. So by adding this graphite and talc, we reduce up to 0.2. That we achieve. And also you can see here the thermal analysis. This green line is pure SU8. It can degrade approx 330. So this is the degradation point. But when we adding the filler at least 100 or 120 degree centigrade, we have improved the thermal, means we can improve the polymer thermal stability up to 450. That was also a good achievement in that work. In mechanical properties also, slowly when we adding the lubricant, solid fillers like graphite, talc and graphite and talc. So these are the, for better understanding I just mix. So we can see here this graphite talc or talc alone gives the better elastic modulus as well as the better means hardness of the component. Then also we can test it for friction coefficient, that is a steady state friction coefficient, means after stabilization of your friction. Initially the friction was high because of the static in nature, and then dynamic friction will occur. So that is the static steady state coefficient of friction. And we can see here that friction, that is in pure SU8 it is 0.78 approx or 0.75. But in case of the 15 GT means 15% graphite and 15% talc gives the very good result, and it is approx 0.2. So it is a very good reduction in the friction coefficient. And also in terms of wear life, you can see here all the component is failed, all the coatings are failed, but this coating up to 4 lakh number of cycles means 24-hour I run continuous that sample, it will not fail. So that was the achievement in 15 GT%. And then wear rate was also, we can calculate it in the logarithmic table. So 15 GT is very less worn out. So this we can also see by this what happened in every lakh cycle. So you can see here after 1 lakh cycle I can saw the pictures, and at the interface also very less debris is there. 2 lakh number of cycles also very less. 4 lakh also coating is still there on the surface. So that was the beauty in this work. But we are not able to achieve up to below 0.1. That was the main goal. So we have added the liquid filler also in the solid filler. So in this work, this is done by my PhD student, and they just use the HBN, hexagonal boron nitride, that is known as the white graphite, and they added the liquid lubricant with HBN also. So here you can see this is the pure SU8, this is the HBN, but when we added the lubricant, you can see the droplets of the lubricant over the surface also. And we also check the surface roughness by atomic force microscopy. So after adding the filler, what we have seen that the nanotextures is formed. So you can see clearly the nanotextures, that is very small, and it is formed over the surface. And due to these nano textures, the wettability is increased, means surface becomes SU8, pure SU8 is having hydrophilic nature. Hydrophilic means your water contact angle less than 90 degree. Hydrophobic means your water contact angle is greater than 90 degrees. So because of this addition of the filler, this surface becomes a hydrophobic surface, and you can see here we can get approx 95.7 degree. That was hydrophobic in nature. Thermal stability also, it can improve lot after adding the liquid filler also. 100 degree approx from the pure SU8. And coefficient of friction also, you can see here coefficient of friction at 2 Newton load we can achieve this 0.1. Okay, but it will not fail. So what we'll do, we can further increase the load when it will be fail. In 4 Newton further it will not fail, it only or friction is also not that much increased, that is steady state, but 6 Newton load it will fail. So that was the maximum load, means 4 Newton is critical load. So hypothesis of these was like one thing in your mind, that MEMS devices that much speed or that much load is not required. They are only required 100 millinewton or less than that. So hypothesis was like if the coating is sustained for higher load, then it can sustain lower load also. Okay, so if it is sustained 2 Newton load, means 200 gram, then it can sustain 100 millinewton and much better than this. Okay, so that was the hypothesis, and it was the restriction in that going to 100 millinewton or 10 millinewton, that was not available, but at least I can prove that if 2 Newton it can sustain, then 20 millinewton it can already sustain, always sustain. So these kinds of the figure you can see here, the surface is not failed in case of the after adding the lubricant, they just lubricant droplets is there. So that was the one case, and this is the recently I published one paper where I, as I told you, that graphite and tall gives the very good result. Then I added the perfluoropolyether, and you can see here all the things like wettability improved 96%, and you can see pure coating, and after adding the filler, simply you can see the droplets of the filler, and that is also throughout the thickness also. Thermal stability improved, elastic modulus or hardness is also improved. Coefficient of friction you can see here, it is approx 0.05. That was the further enhancement in the coefficient of friction. And why that after adding the filler, you can see clearly here this track where we move. So the layer of the lubricant you can clearly watch in that. There is no material displacement, only the track displacement. Liquid is displaced from the one place to another place. And also you can see that liquid on that interface, ball interface clearly. So that, and EDS spectrum also clearly tell that the transfer of the fluorine on the interface. And this was the beauty of this work. Then after that I also fabricated the composite tip. That is a micromechanical, we can see that is a few micron, 500 micron, and the similar type of the result we have obtained, so that we concluded our that particular thesis, and similar redox result I showed that transfer of the fluorine is there, due to which your friction is less and life of the tip is also improved. So now we move to the next part of that particular bearing. So why need of the travelogy in bearing? It fails, it can create the cavity due to the low oil supply, due to the poor running condition. All these factors means fails your bearing fast. So how we can improve? And nowadays our green environment is very important, because when we are using the bearings, we requires the external lubricant. But nowadays government is telling that we can make the green environment. So how we can make the green environment? Only we are not using the more lubricant. So that is only possible by addition of the polymer. So some researchers gives the coating is the one solution. In coating also, there are two types of the coating: hard coating, soft coating. Soft coating is good for coefficient of friction, but not good for wear. It will fail fast. Hard coating, it is good for wear resistance, but not good for the frictional coefficient. So what people have suggested in that literature, that we can make the sandwich. We can use the both property. We can make hard coating, then soft coating, then hard coating and soft coating as per our requirement. That is few nanometer. So that was beauty. Then we can increase the both. We can get the low coefficient of friction as well as the high wear resistance property. So that was the solution one proposed by researchers. And after that I also did adding the coating and water contact angle. I just check it and it is hydrophobic after adding the filler. And we can also, you can see that the elastic modulus is also improved. Then coefficient of friction, you can see EGSN means epoxy graphite. SN is the base oil, that is a group 5, SN150 that is used in automobile. And we can get the 0.1 without any lubricant. And these test I run up to 24 hours. After 24 hours, I only get the data and that is presented. So approximately why it is there, EGSN. You can see here the nanotextures are formed. Due to the nanotextures, the surface is hydrophobic, and due to the hydrophobic, adhesion is less, and it shows the low coefficient of friction. And wear is also very minimal. We can't observe, and when we enlarge, there is very smooth surface, you can observe it. And it can tested at 2 Newton load. So these type of the coatings, it is helpful for low load applications. High load applications, there is still a research gap in this field. So you can think of how we can develop for high load also. Another, this was the BTech work. BTech student finally did it in 2019. And I told you just develop the bearing balls. So if we can polymer, ceramic balls is there, steel balls is there, so why not bearing balls? So that was the biggest challenge, how we can develop, so we can make the mold of acrylic, that hemispherical mold through milling, and then we can make these bearing balls. Okay, that is a standard 12.7 mm diameter. So these balls we can test it in 4-volt tester. Coefficient of friction, we can see here graphite talc still gives the lowest coefficient of friction. So here no lubricant we are adding. We are only adding the graphite and talc. And pure epoxy, you can see immediately it will fail, and it will, you can see sometime due to the heat, it is re-solidified at the interface. So these are the observation which we observed. But in case of graphite and talc ball, we are not observed that much scar. Only the plastic deformation occurs that change the shape, but it is not wear out. Okay, so that is also used for low load application, like in your chairs. You can use it where it is no lubrication is required. It is very helpful. And also it is if your wear scar is less than 4 mm, then it is acceptable in range, that is ASTM standard. So graphite talc bearing ball, it is acceptable in nature. And further we have tested for compressive strength and their polymer. You know that we are only tested the SORD hardness test. We are not conducting Rockwell, Brinell or Breaker hardness test. That is only for metal. So polymer SORD hardness test is only used as per the ASTM standard, and we observe that graphite talc ball is good in terms of the compressive strength, in terms of the wear scar also. So this is the final slide of my presentation. What is the takeaway or what you can do it in further your masters if you are interested, or in your doctorate. You can know that the polymer is self lubricating, and you can play with the fillers, and you can enhance the property as per your application. You can select the fillers as per the, after addition of fillers, either micro or nano fillers, you can enhance all the properties, and you can use this for MEMS fabrication and bearing application. Another way is the polymer paint, which we are doing in the automotive. That research work is still one of my PhD student is doing. Is he are going to develop the polymer paint for anti-wear, anti-corrosion, and antibacterial test we will conduct it, because in automotive or transport sector what we happen, we required the antibacterial paint, then bacteria can reflect it. So you also maybe saw some advertisement from Deepika Padgone say this is the antibacterial paint. Now no bacteria comes inside your house that reflect or revert back your bacteria from your house. That type of the development, Narrow-Lak or Asian paint, they are spending huge money in developing the antibacterial paint. So that is one research work which are recently one of my doctorate student is doing. That is for automotive application. They are developing the nano composite paint which can show their antibacterial, anti-friction or anti-wear or anti-corrosion, because these are three things very important for any automotive. And that is succeed also, because their one BTech group did it, that startup of that particular base things. So they just tested for 5 bacteria which is available in our biotechnology lab, and it was succeeded that those bacteria is, even though after 24 hours they have not harms anything in coating, because that after striking the bacteria we just kept for 24 hour or 48 hour, that is sufficient time. If any reaction is there, we can observe through the microscope, and if any change you can get it. So that nanocomposite paint is going to develop, and that was the good work. And those both BTech student got one go for the masters, and one got in JWL, that automotive industry. So because of final year project is very important in your BTech. If you can do much better work, then you will get the surely a very good job, and everyone required the good person, good knowledgeable person. Your BTech project is very important, so choose wisely as per industry, which industry you want to go. That is very important. So thank you. If you want to read something, these are my books, edited books in Travelology, all books, and these are my authored book. If you are very much interested in modern manufacturing technology, Industry 4.0, that I wrote this modern manufacturing technology. If you are interested in lubrication, different types of the lubrication, and what are the application in bearing, that sustainable lubrication. And this is the book recently already came in the market, that is a sustainable composite. So sustainable composite is also wear out, that is used in a structural, automotive, aerospace, aircraft, all are natural fibers we are using. Sustainable composite is nothing but natural fiber we are using, that is a green composite. So what are the things people have already did it, and what new things it is there, all are present in those books. So all, if you are interested, all books is available. Thank you very much for patiently listening, and I hope everyone likes that lecture. And I saw that nobody blinks their eyes in 1 hour is over. Thank you once again. Any questions? Yeah, please try. Yeah. Yes. Photoresist, like you are developing, like previously negatives was there. So that photoresist nothing but like a electrolyte or something. So photoresist is nothing but positive photoresist means when light will fall. So exposed area will means unexposed area is solidified and exposed area will be dissolved. So that is a means of positive photoresist. So means if you want to make a structure, then you can make a mask, because we want to precise dimension, then make a mask, and then light will fall over the surface, UV light. Okay, so wherever the unexposed area, that will be solidified, and exposed area you can wash up via the electrolyte. So that is called a positive photoresist. Negative photoresist is just opposite. Exposed area is solidified and unexposed area is not solidified. So that is a SU8 structure that nowadays it is using in coating of those silicon wafer in your hard disk with some fillers, because MWCNT is used in your hard disk coating of your hard disk, few nanometer, 2 nanometer, then that is a sandwich kind of the layer, hard, soft like this. And when your lubricant, that solid lubricant will be exposed completely, hard disk will be crash. Another example, when you you have not observed that one, but you face daily, when you shut down your laptop and keep it for 10 to 15 days, then what happens, that tip and stick with the due to the wonderful force stick in your hard disk, that there. So when you restart after 10 days, what happens, it takes more force to detach from that surface. So due to that, what happens, your heat is generated more, and backside you can feel that the huge heat developed by your laptop. Okay, sometimes if it is more, then maybe the chances of your laptop crash is also there. So means after 1 month you can see that sometimes your laptop is crashed. You can say that I have not opened, I opened 1 month back, it was good. But that is the reason. Due to the friction is more, van der Waals forces are more in a small scale. But in macro scale, van der Waals forces is the weak force. But in micro or nano scale, it is a very strong force. Okay, due to that reason, your laptop crash, your mobile phone is crash, mobile phone is heating more, like Apple iPhone or something, they are spending more money on the coating. That's why they are not heating, even though you are talk 5 hours or 6 hours, but when you purchase 5,000 rupees iPhone, then you can see the heating problem is more, even though you talk within a 30 minutes or 1 hour, heat is more. So sometimes due to that particular heat, your mobile phone is blast. So that's why Apple phone or a MacBook, all are spending huge money in that particular coating. They are developed the gold coating or some polymer coating, so that enhance their life. That is the that's why the cost is more of iPhone or MacBook. That is the reason. So their manufacturing cost is itself 50,000. Then they are selling their 70,000 or 80,000, whatever. Any other questions? Yeah.
Sir, can we use it in 3D printers?
Yes, we can use it. We can make the wires of SU8, because
Okay.
that is a epoxy. Epoxy, we can make some wires,
Yes.
and then we can use it in 3D printing.
Okay.
That we can do.
Thank you, sir.
Even though we can, in bio medical side, that is known as a biotribology. So hip joint or knee joint also we are developing some biopolymer composite coating in your knee or something, whatever. So nowadays you can see that if you have any arthritis problem or something, and you have pain in your elbow or knee or hip, so you can replace it, and high flexible joints are coming. So you can fold your leg very flexibly, and previously it was not there. Previously the life of, we are replacing the only steel, and that is corroded sometime and it is very harmful. So operation you can do only after 2 years or 3 years. Life of that particular knee joint or hip joint is 1 to 2 years. Nowadays, 10 year, 15 year it will go.
So actually, I'm working on that. I'm a,
It is possible.
thank you, sir.
Any more questions from the audience? Okay, thank you so much, sir.
Thank you once again to organizers of Amity University Flame 2022 and volunteers also. Thank you once again, and because of your hard work, it can't succeed. Volunteers is very important for success of any event. That is very important, and I think biggest thanks to volunteer.
Thank you so much, sir. Thank you for this wonderful lecture. Now I would like to invite Dr. Kanojia to come on the stage and provide the guest speaker with the thank you memento. Bhai, हट जा, ओए, भाई, Okay, now let's move to the next phase of this session. And let me call the participants one by one. There is a... Okay. Okay, so first and foremost, let me introduce you to our session chair, Dr. Mittal. I may now introduce you to Dr. Mittal, he started his career in the education industry in 2000 with Amity Group. Currently, he is working as Head Associate Professor in the Department of Mathematics, Amity Institute of Applied Sciences, Amity University, Uttar Pradesh. He earned his post-doctorate from Hanyang University, South Korea in 2016, PhD from the University of Delhi, India, and post-graduation in the Applied Mathematics from IIT Roorkee, India in 2000. May I request sir to please come on the stage and say some words. Yes, sir. So,
Hello.
Sir, please present the sapling to Dr.
Hello.
Mittal. Thank you so much, sir. Let's move to the next phase of this session. I would like to make an announcement for the participants. Please keep your lecture between 10 to 12 minutes as we are short of time. So first of all, I would like to call the first paper ID of this session, paper ID number 594.
Thank you. So first of all, very good afternoon to everyone. My name is Sejal More. I'm a BTech Industrial Engineering student from Vishwakarma Institute of Technology, Pune. So the title of our research paper is Facility Location of Ambulances using K-means clustering and Minimax. So this is the flow of presentation. So basically this paper is a survey which is conducted on Nagpur-Amravati highway for understanding the cause behind the increasing number of accidents or mortality rate. So basically in India, accidents occur every 2 minutes. So for this research purpose, we underwent some of the surveys. So based on that, we found that in 2022, around 1,16,498 road accidents occurred on national highways, including the expressways. So among all the accidents that are occurring in India, most of the accidents are occurring on national highways, state highways and expressways. So in specifically Maharashtra, 941 accidents occur in 2022. So this is the latest data which was gathered from the National Authority of Highway, India. So for this research, basically we identified the accident spots on the Nagpur-Amravati highway. So these are the accident spots found, which is 8th mile. So the name of these accident spots are 8th mile, Vardhaman, Chokardhani, Bajargaon bus stop, Junapani bus stop, Oriental Plaza, Karanja Gadge bus stop, Satnavari. So these are the accident spots which we found on the stretch of the 75 kilometers Nagpur-Amravati highway. So the literature that we referred for this particular study, it so mostly it revolved around using the advanced technology in the accident prevention zone. So one of the research paper also mentions the using of VANET technology, which is vehicular ad hoc network, using the TARS, that is time using Indian constellation. So this some of the techniques suggest that using the IoT for accident reduction. So placing IoT systems on all the cars, so that as soon as accident occurs, there will be uh, like these IoT systems will transmit the signal to the nearest ambulance. So some of these advanced technologies are suggested through this research paper, but no or very less amount of research is done to so it basically lacks to emphasizes on such cases uh, which happen due to lack of ambulance availability in the area or absence of ambulances. So for this purpose, the major problem with this Nagpur-Amravati highway is there are presence of ambulances, but the ambulances are present in less amount. Also, in some area there are no ambulances. So for this purpose, we are using the Minimax and K-means clustering method to identify the proper location of ambulance so that the response time after the accident occurs can be minimized. So the majority of accidents are occurring are due to the overspeeding, negligence of the traffic rules, etc. So the average amount of time for reaching, so basically on this stretch of 75 kilometers, there are two tollways, and the ambulances are present on both these tollways, toll plazas, and the average amount of time required for these ambulances to reach the accident location is 30 minutes to 60 minutes, depending on the location. So, which is a huge amount of time in case of fatal accidents. So, thus we are proposing this placement of ambulances on such location which can reach the accident spots on minimum amount of time. So, basically this K-means clustering is a centroid based algorithm where K is the number of clusters to be made. So every point is assigned to its nearest centroid based on the sum of square. So it uses the rectilinear distance. So based on that, as we can see on the lower right corner, there are two clustered form. So the first cluster consists of the 5 locations and the second cluster consists of 3 locations. So this is the Minimax facility location problem. So basically this Minimax method is used to minimize the maximum distance between these 2 points. So these are some of the accidents, these are the accident spots which we identified, and this is the, this H represents the Minimax location which for this accident spots. So on the stretch of this So this minimax location is basically two coordinates, and the line joining these two coordinates will consist the ambulances. So our result was that we found these two locations, which is Chinch, Bhuvan and Varda. So these two specific location, placing this ambulance on these two specific location can reduce the response time of the ambulances to reach the accident spots. So basically Chinch, Bhuvan is for the first cluster, which consists of 5 location, and the Varda is for the second location, which consists of 3 accident spots. So we are trying to reach the authority so that we can conduct a survey of how much amount of time can be reduced by placing these ambulances on the identified spot. So this was the study that we did. So these are the major references, some of which I mentioned while speaking about the literature review. Yes, thank you. Yes, sir.
Any questions from the audience?
So you have used k-means clustering. Any other algorithm available
No,
which will give better results?
sir, to means evaluate if we are using a correct algorithm. So k-means clustering will give us the number of clusters to be made. To evaluate if we are using correct number of optimal number of clusters, so we have used another method called gap statistic method. So to inspect if the number of clusters are optimal or not, there are basically 3 type of methods: elbow method, silhouette method, and gap statistics. So along with this, we are using the gap statistic method.
And how you are getting the data of the from Google Maps, or how you are getting the data? Live?
Yes, sir.
It is live or a static thing?
Sir, we are using from Google Maps.
Is it working project or what?
Uh, Working as in,
Means you
have
have
we
generated
implemented?
everything, or code is working or not?
Yes, sir, the code is working and we are getting the results.
But your graphs and all the tables is not visible in the PPT. You saw that it's very small size. So I was not able to understand the
Yes,
graphs.
actually, the stretch of was the highway was quite big, so we were trying to put the whole picture there, maybe.
5 meg. Okay, thank you.
Okay, thank you, sir.
Thank you so much for this wonderful lecture. I want to make an announcement for now. We need to stop this session as there is an online session going on. So after that session, we'll be continuing this session.
यार कैसे लगेगा ये नहीं ये इस पे MS Team नहीं है क्या
इस पे हो जाएगा सर, ऑनलाइन चल जाएगा ना।
तुम्हारा लैपटॉप
मेरा नहीं है सर, यही
इसका
का
ही
है, एमिटी का है।
MT पे MS Team ठीक है इस पे
होना तो चाहिए सर। पहले
टीम सर्च
इसको एकदम वो कर दिया इन्होंने।
सर मैं 1 मिनट बात करता हूँ
Gaspar, are you there?
Hello, sir. Can you hear me? Yes, he can hear.
Yes, I can.
Good morning, sir. Welcome to the session. So I would like to introduce Professor Gasper to everybody. Professor Dr. Marcel Gasper was born in 1987 in Hungary, graduated from the Faculty of Mechanical Engineering and Informatics of the University of Miskolc as mechanical engineer, masters in 2011, and IWE welding engineer 2013. He was a PhD student from 2011 to 2014, then an assistant lecturer. He earned his PhD degree from physical simulation-based development of welding technology for quenched and tempered structural high-strength steels with summa cum laude in 2016. He is an associate professor and the head of the Department of Structural Integrity, furthermore, the leader of Welding Research Group. So, good morning, sir, and I would like you to continue for this lecture.
Thank you very much. Thank you, thank you for this nice introduction. I would like to also welcome everyone. Now I shared my screen. I hope it is visible.
Yes, sir, it is.
Super. Thank you very much. So it's a big honor to me that I can have this presentation today in India. Actually, I have a very good knowledge about your country. Even at our university, we had some colleagues from India, and I'm very interested about the country and also the technology development university activities there. I really hope that in the future I will have the chance to visit the country. In my keynote lecture, I will have a general presentation about the challenges and possibilities in the welding of advanced high-strength steels. In my presentation, I will have some introduction about our university and our research activity. Then I will have some information about different kind of high-strength steel grades and their production processes. Then I will continue with the weldability challenges, and finally I will try to provide some possible technological solutions how we can handle these new generations of high-strength steels. Why is the topic of high-strength steel? Actually, you may know that Hungary is a little tiny country in the middle of Europe. But even though we are a small country with a population of 10 million people, there are numerous automotive and vehicle industrial companies within Hungary. So in this map, you can see that we have the factory for Audi, Mercedes, BMW, Suzuki, Opel, and also their suppliers are located in Hungary. And besides automotive industry, also there is the production of trains, for example at Alstom or Stadler. So there are a lot of companies who are working in the field of this automotive sector, and you may know that the most part of the application of high-strength steels can be connected to vehicle industry. Some small information about our university. The University of Miskolc was among the first technical universities of the world. Actually, our predecessor was established in 1735 in Selmecbánya, which today belongs to Slovakia. And then in 1949, the university moved to Miskolc, to my hometown. And nowadays we have 9,000 students in 8 faculties. And I work in the Faculty of Mechanical Engineering and Informatics and in the Institute of Material Science and Technology. And as you can see at the right upper part of the photo, that we have the license for this international welding engineer programs, and we regularly organize this course for postgraduate students. The organizers very nicely introduced me and my activities. Actually, I work as an associate professor here at the University of Miskolc, and I'm responsible for the welding research group. I have the license for international welding engineering, and otherwise I graduated as a mechanical engineer at the same university where I'm working now. And now start the real content of this presentation. Here you can see some application fields related to high-strength steels. High-strength steels are applied in vehicle industry, as I mentioned before. Automotive sector is a very well-known area of their application. If you see this car body, the yellow and red marked parts of the body structure produced from extra or ultra high-strength steels in order to have a safety place for the passengers in the car. Furthermore, significant weight reduction can be achieved by the application of high-strength steels. Besides cars, also in trains, trucks, and also in mobile cranes, high-strength steels are used. According to my knowledge, in this kind of mobile cranes, there is a 960 strength category of high-strength steels, and even sometimes 1,100 categories are available as well. High-strength steels can be also found in the military industry. Here you can see that there is a military bridge which made from SSAB steel, so it is from a Swedish steel, and it's produced from 1000 megapascal yield strength steel. And also in the agriculture area, it's important to use high strength steels, because if high strength steel are used, these agricultural vehicles are lighter, and they can degrade less the ground, the soil, because if they are too heavy, there will be a large amount of degradation of the soil and the ground, but if they are lighter, they can keep the original characteristics of the soil, so the quality of the plants will be better. The clear advantage of high-strength steels that we can reduce the plate thickness, and therefore we can achieve a significant weight reduction of the structures. Besides it, it's also a possibility to have some savings during the production, because we need less steel. We need less filler metal during welding, and therefore the production time of these structures can be lower as well. Furthermore, if we consider the operation of the structures, especially mobile structures from high-strength steels, we can see that less fuel is needed. So it's very good and economic that we don't need to spend so much money on petrol. Furthermore, for environmental purposes, it's a clear advantage that there is a much lower carbon dioxide emission when we use mobile structures made from high-strength steels. However, on the other hand, we should consider that these materials are more expensive. Although less material is needed, but their price per kilogram is generally higher, 2-3 times higher compared to conventional steels, and the filler materials are also more expensive compared to conventional filler materials. There are also design challenges. So this high yield strength, because in the area of mechanical engineering, in the most cases, we design the structure based on the yield strength. If it is a clear tensile loading, we can fully use the advantage of high strength steel. But if it's a, for example, compression stress or fatigue or buckling of the structure, in that case, these high strength steel are not as advantageous as we would expect. So there are always a challenges which part of the structure should be produced from high strength steel. Weldability is also a hot topic. Basically, these steels have a non-equilibrium microstructure, mostly martensite bainite microstructure, and these different kind of variations. Even sometimes some austenite content can be identified in the microstructure. The mismatch phenomena is also a hot topic, how we can select the proper filler material to the welding. And of course, special technological solutions are needed to have at least the similar strength and toughness joined as the base material. In my presentation, I will focus on the weldability topics, but based on this screen, you can see that it's a more complex problem. And now I would like to continue with the introduction of different kind of steel grades and their production. I think this kind of diagram is familiar for you. It is also called as a banana curve. On the perpendicular x, you can see the elongation, and in the horizontal x, you can see the ultimate tensile strength. Generally, this diagram illustrates the high-strength steels applied in the automotive sector. So generally, thin high-strength steel materials, plates not plates, sheets are illustrated in this graph. And since the body parts of the vehicles need to have a good elongation as well, besides the high ultimate tensile strength, due to the deep drawing and the different kind of metal forming processes. Therefore, it's very important that we need a high strength and good elongation characteristics at the same time. The clear development tendency in this field to have extra and ultra high strength steels with higher strength and higher ductility. These are called the so-called second and third generation of advanced high-strength steels. Besides automotive sector, high-strength steels are also used as structural steels. However, the types and the production processes are different. In this figure, you can see a little history of the development of high-strength steel. 50, 60, 70 years ago, the top category was the S355 strength category, where the yield strength, the guaranteed minimum yield strength, was 355 megapascal. These steels were produced by heat treating process and rolling process. Generally, the heat treating process was normalizing. In the mid of 60s and around the 70s, the quenching and tempering process was introduced to steel production, and this is the real start of the application of high-strength steels. You can see that by quenching and high temperature tempering, today we can reach even 1,300 megapascal yield strength steels, yield stress steels. However, I should mention that in terms of the welding, matching type filler materials when the weld has a similar strength as the base material are only available up to 1100 megapascal. Besides quenching and tempering, thermomechanical rolling process is a very good technology to increase the strength. As you can see, with this technology, we can reach nowadays even 960 megapascal. So there is approximately a kind of 15-20 years difference between achieving the same strength grade by the different kind of technology, but TMCP process can be considered as quite competitive compared to quenching and tempering. Related to the production processes, you may know that during normalizing, we are using a simple heat treating process with one cycle. We are going up to the homogeneous austenite region, and then we are using a simple air cooling. In case of quenching and tempering, we need to use a much faster cooling. Therefore, water cooling is used, which is followed by a high temperature tempering under the A1 the kind of martensite after water cooling, and then making tempering in order to make a more equilibrium microstructure with some carbide precipitates. This is generally called as spherodite. Related TMCP process, different kind of processing routes are available. Generally, the process is always starting with a kind of hot rolling, but then the rolling process is started and continued even below in much lower temperature, around the A3 temperature, and sometimes even below the A3 temperature. And then very fast cooling is used. Therefore, an extreme low grain size can be achieved with this technology. When we would like to apply high-strength steels, we should consider that by the increasing strength, generally the elongation, so the ductility is reducing. And actually, if we compare the ratio of yield strength and tensile strength, we can see that above 600 MPa, this ratio is quite close to 1, which means there is no plastic material, so there is no difference between the yield strength and the tensile strength, and in parallel the ductility reduced as well. How they can achieve these high strengths? Besides the processing routes, of course, different kind of alloying elements are needed. Firstly, I should highlight the substitution solid solution elements, such as manganese, silicon, chromium, or molybdenum. And besides them, there are also some interstitial solid solution elements, of course carbon, and in some cases nitrogen. Microalloying elements have generally a very important role in high-strength steels, especially in high-strength low-alloy steels. We can find aluminium, titanium, niobium, vanadium, and boron in this kind of high-strength steels. Especially in quenched and tempered group, we can find boron in order to increase the hardenability, the so-called quenchability of high-strength steels. The steel producers generally focus on reducing the sulfur and the phosphorus content in order to have high toughness in these steels. And they are also using, as I mentioned before, heat treating and thermomechanical rolling. With these technologies, a very fine-grained microstructure can be achieved, which generally a non-equilibrium microstructure with the combination of martensite bainite, but also different kind of carbides, remained austenite, in some cases ferrite, can be also identified in these high-strength steels. Some measurements have shown that there is also a higher dislocation density in the material, which also resulting higher strength, and there are precipitates thanks to the precipitation hardening alloying elements such as chromium or molybdenium, which can be considered as carbide former elements. Here you can see a microstructure, a typical microstructure of quenched and tempered high-strength steel. You can see it at the left-hand side. And at the right-hand side, you can see a typical microstructure of thermomechanically rolled high-strength steel. Both microstructure has a fine-grained structure, but the grains are even finer in TMCP steel. In TMCP steel, the grain size in some cases in just some microns. Now I would continue my presentation with the weldability challenges. If we consider the weldability of different kind of structural steels, the best option, if we use the Graville diagram, actually this diagram having three areas. In the first area you can find those steels which are very easy to weld without controlled heat input and preheating. In the second zone you can find steels which are a bit more problematic, but generally they can be also welded without any cold cracking. And in the third area you can find the most sensitive steels when high cold cracking sensitivity is identified and when you need to use preheating and also controlled heat input. In this diagram, me and my colleagues summarized the data of different kind of base materials based on the base material certificates and the chemical composition, and then we put these materials into this diagram. On the horizontal X, you can see the Graville carbon equivalent, which are a little bit different compared to the IIW carbon equivalent. Actually, the difference is the silicon. So according to Graville, the silicon has also an important effect on the cold cracking sensitivity. But even though the carbon equivalent is high, if there is no carbon in the steel, there won't be cold cracking sensitivity. So this diagram is clearly demonstrates that the carbon content has the most important role on cold cracking sensitivity and therefore the weldability. If we consider quenched and tempered steels and TMCP steels, actually the same strength categories. So if you see the 960Q steel, which is located in the area 3, and if you consider the 960M steel, which is located in the area 1, we can conclude that the thermomechanically rolled steel from the same strength category less sensitive to cold cracking and therefore much easier to weld this grade even without the use of preheating. This slide summarizing the weldability challenges of high-strength steels. The first topic is the higher cold cracking sensitivity. The cold cracking can be originated by the combination of hydrogen diffusion, tensile stress, and high carbon equivalent, so brittle martensitic base material. These kind of cracks can occur in the heat affected zone, as you can see in these fillet welds, but they can also occur in the mid of weld. These photos was performed by our industrial partners, and generally they find in their welded structures from high-strength steels this kind of transversal cracks in the weld. Another topic is the inhomogeneous heat-affected zone, where the toughness significantly reduced compared to the base material. Furthermore, hardened and softened zones, as you can see in this graph, are also located in the heat-affected zone, depending on the distance from the fusion line. The third interesting topic is the filler metal selection, the so-called mismatch ratio. It's always a question whether we need to use a matching, under-matching, or over-matching filler metal, in which kind of filler metal we can make a better quality joint in terms of the different kind of loading characteristics. The question arises, which one is the larger problem from the perspective of the quality, the cold cracking or the toughness reduction? After consulting with many welding engineers, we had the conclusion that the toughness reduction is a bigger problem, because if we consider the production route of welded structures, the structures are welded, and then before it's transported to the customers, there is always a non-destructive testing, for example, ultrasonic testing, radiography, or simple visual testing, penetration testing. So the presence of cold cracking are always identified. So generally there is very low risk that we have a welded structure in the market with cold cracks. But for toughness, we do not have any information. Just the quality assurance is the tool in the hand of welding engineers, because in the real welded structures, when the structure is ready, it's not possible to identify the toughness properties, the ductility, with non-destructive testings. So only destructive testings are possible, but in that case, these structures cannot be used later. So therefore, during the production, it's need to focus on toughness and quality assurance, and to keeping the requirements for the given steel during welding. So therefore, in my presentation, I will focus on the toughness characteristics. Generally, in high-strength steels, especially during welding, there is a significant toughness reduction. One of the reasons is the relatively high carbon equivalent. Another reason is the grain coarsening close to the fusion line. And the third problem is the presence of local brittle zones, so-called martensite-austenite islands. If you see this schematic figure, you can see that if there is a brittle phase in the microstructure, it can lead to cleavage cracks, especially when there are large grain size. This kind of local brittle zones can be identified by special microstructural analysis and by special etching technology. The so-called Lepera etching is a very good tool to identify the brittle parts in the microstructure. In these figures, these brittle parts are illustrated with this white color, thanks to this kind of special Lepera etching technology. During the weldability challenges, the heat-affected zone characteristics are always in the focus of the research. In terms of the toughness properties, generally the coarse-grained heat-affected zone, the intercritical heat-affected zone, and the intercritically reheated coarse-grained zone are considered as those areas of the joints where there is the lowest toughness. This kind of intercritical coarse-grained zone can be formed when there is a multipass weld, and you can see that after the first weld bead there will be a normal coarse grain zone, but due to the heat input of the second weld bead it will be heat treated again, and that part which will have a kind of intercritical heat treating, here this will be the so-called intercritical coarse grain zone, where generally large amount of local brittle zones are formed in the welded joint. Here you can see that in case of the 960 quench and temper steel, we performed optical microscopic analysis and microhardness examination on a real welded joint, and we can identify that in this intercritical coarse-grained heat-affected zone, the inner part of the grains generally soften compared to base material having a hardness of maybe 200, 260, but at the original, the primer austenite grain boundaries, where these local brittle parts, mostly martensite austenite parts form, the hardness can go up even to 360, 330. So this is showing the special characteristic of the microstructure, which should be focused during the research. Physical simulators, such as the Weber 3500, provides a unique solution for the production of critical heat-affected zone areas. You may know that in real welded joints, the extension of the heat-affected zone areas is relatively small due to the low heat input, and therefore they can be limitedly investigated by conventional materials tests. But with this kind of equipment and its resistance heating system and cooling device, we can realize the welding heat cycles, and we can perform homogeneously the desired heat-affected zone based on the different kind of heat cycle models, such as Ricallin's 3D, Rosenthal's 3D. During our experimental work, we analyzed the heat-affected zone characteristics of this 960 quenched and tempered steel. For the coarse-grained heat-affected zone, we use the 1350 peak temperature. For intercritical heat-affected zone, 775 degree Celsius peak temperature, and we used its combination for the intercritical coarse-grained zone. We analyzed the characteristics of the heat-affected zone based on the T8/5 cooling time, which is very crucial in terms of welding, because this is the cooling time between 800 degrees Celsius and 500 degrees Celsius. So generally the 2.5 sec is illustrating the laser beam welding, electron beam welding circumstances, while 30 sec or 100 sec can be relevant in terms of submerged arc welding or other kind of high heat input technologies. Here you can see the simulation heat cycles for the coarse grain zone, for the intercritical zone, and for the intercritically reheated coarse grain zone. All of these curves were generated based on the Ricallin or Rosenthal 3D model. After the successful simulation, we performed scanning electron microscope analysis. On the left-hand side, you can see the original.
I think 546 is not responding. That's why, can I start my presentation?
sorry. So on the left-hand side, you can see the base material characteristics, and the right-hand side, the properties of the coarse grain zone. As I mentioned, these steels generally has a martensite microstructure, but you can see when a high heat input is used, even a kind of bainitic characteristics can be identified. In the intercritical and the intercritical coarse grain zone, you can see the local brittle zones that can be observed and at the original grain boundaries. If we consider the hardness properties and if we analyze the hardness in terms of the cold cracking sensitivity and base material, we can say that as we reducing the heat input, the hardness is increasing, but generally there is no risk that we achieve the requirement of 450, which would say high cold cracking sensitivity. And softening generally does not occur so much in these steels. Sometimes in high heat input in the intercritical zone, some softening can be occurred. Compared to 960 to a conventional S355, we can see that in medium or high heat input, there is a large difference in the hardness of the coarse grain zone. But as we are going down with the heat input and the cooling time, the hardness values are quite close to each other. Regarding the impact energy and the Sharpie V-notch test results, we can say that there is a very significant toughness reduction in the heat-affected zone. Just imagine the base material often have a toughness even 160 joule at minus 40 degrees, but generally the impact energy values decrease to the level of the limit of the governing standards. The question arises whether we can be satisfied with this kind of impact energy in the heat-affected zone. According to my opinion, we cannot be fully satisfied. Although the requirement is often fulfilled and we are above the requirement of 27 joule, we can see during instrumented Sharpie V-notch testing that the heat-affected zone generally behave fully brittle. There is no stable crack propagation in the measured force displacement diagrams compared to the base material, where you can clearly identify in the graphs stable crack propagation, and generally only a little unstable crack propagation is observed. But in heat-affected zone, the coarse grain, the intercritical heat-affected zones always behave very brittle, as you can also see in the fracture surface of the Sharpie specimens. There is no any real plastic deformation, so it's a very brittle cleavage-like fracture. Therefore, it's very important to minimize the extension of the heat-affected zone, because the heat-affected zone is very brittle in this kind of quenched and tempered high-strength steels. Besides quenched and tempered steels, we performed analysis on dual-phase steels applied in the automotive industry. From DP800 to DP1400, different grades were observed in the 5 and 30 sec cooling time. And in this kind of dual-phase steels, we can say that hardening is relevant mostly in the coarse-grained heat-affected zone when low heat input is used, so generally 5 sec cooling time. But as we increasing the cooling time, there won't be any hardening in the heat-affected zone. Furthermore, the heat-affected zone will rather soften. Since in automotive sector, mostly resistance welding and laser beam welding is used, therefore the 5 sec cooling time is more relevant for the user compared to the long cooling time. Therefore, we need to focus a bit also on the hardening of this heat affected zone as well. Now, after seeing the challenges in the weldability and welding, let's see how we can handle these problems. In conventional gas metal arc welding, of course, we need to use preheating, especially for quenched and tempered steel. For preheating, we use different kind of methods. We need to use a limited welding heat input, and we need to consider the optimal T8 per 5 cooling time range of the steel producer. We need to use a strictly limited interpass temperature in multipass welding, and if it's possible, we need to use advanced pulsed welding technologies. As you can see, the welding parameter toolbox is very small, so the parameters can be selected from a very narrow range. During our experimental work, we analyzed the possibility of post-weld heat treating. Actually, with the Gleber simulator, we tried to analyze what's happening in the heat affected zone if we are using a kind of tempering heat cycle. So we used the 650 degrees Celsius peak temperature tempering after the coarse-grained, intercritical and intercritically reheated coarse-grained zone. Actually, in the industry, for example, by thick dressing, the welds and the heat affected zone often get a kind of post-weld heat treating, mostly for the cutting properties, but no one examining the toughness characteristics. Here you can see the change of the microstructure thanks to this localized 650 peak temperature tempering, and here you can see the measured Sharp-PV energy data. As you can see, in all investigated subzones, after post-weld heat treating, the toughness improved a lot. You can also see it in the graphs. This was the original intercritical heat affected zone force displacement diagram during impact testing, and this one is the force displacement diagram after post-weld heat treating. You can see that the intercritical heat affected zone behave fully ductile after this localized post-weld heat treating. Localized post-weld heat treating can be also performed, for example, in industrial practice by laser welding. Here you can see one of our experimental work when diode laser equipment was used for the welding of different kind of dual phase steels. And after, with the similar diode laser equipment, we performed localized post-weld heat treatment by a top temperature of 650 degrees Celsius. Here you can see some information of the parameters. You may know that diode lasers are very advantageous because the heated area, the spot size, can be set, can be adjusted in a wide range. So for welding, we use the 2 multiplied 2 mm spot size, but for post-weld heat treatment, we use the much larger rectangular shape based on the weld and heat affected zone area. Here you can see the consequence of the localized post-weld heat treatment on the different grade of DP steels. You can see that the peak hardness in the coarse-grained and in some cases in the fine-grained heat-affected zone can be reduced to the level of the base material. So the localized post-weld heat treating by laser is very advantageous to reduce the hardness, reduce the cold cracking sensitivity, and probably increasing the toughness of the heat affected zone. Here you can see some information about the tensile test results. These joints were performed as autogenous welding, so filler metal was not used. However, by filler metal, even better tensile results can be achieved. If we examine the residual stress distribution, the longitudinal stresses and the transversal stresses by X-ray diffraction, we can see that thanks to the post-weld heat treatment, the tensile residual stresses can be reduced even to the level of zero. So from tensile stresses, we can make mostly compressive stresses in the welded joints close to the surface, which can be very advantageous for fatigue loading. Our last example will be some solution for electron beam welding of thicker high-strength steels, so for quenched and tempered and TMCP high-strength steels. With electron beam welding, we can use one-pass shape welded joint, even at the thickness of 15 millimeter. Here you can see the experimental circumstances in the vacuum chamber of the equipment, and here you can see a result. If we compare the hardness distribution in an electron beam welded and a gas metal arc welded 960 quenched and tempered steel, we can see that in electron beam welding, in the fusion zone, heat affected zone, there is a significant hardening, what we do not above the permitted 450 Vickers limit. In GMEW, the hardness is much variable. In the face side of the joint, the values are close to the 450 Vickers, and in the root side, thanks to the multipass welding, not hardening, but rather softening occur close to the root. If we consider the tensile strengths, that we can say that by EBW, the same strength joint can be produced as with GMEW without the application of expensive filler metal. Furthermore, here you can see a comparative study of the characteristics of weld shape. We can say that by electron beam welding, the weld size is 10 times smaller compared to GMAW, and the heat affected zone is also 3 times higher compared to GMAW. So, in total, the mechanical properties won't reduce down so drastically compared to conventional arc welding technologies. If we compare the characteristics of the 960 grades in quenched and tempered and TMCP condition, we can say that TMCP high-strength steels are very ideal in terms of the hardness. There is no significant hardening in the weld and in the heat-affected zone compared to quenched and tempered steels. And if we analyze the impact energy values, we can also see that by the thermomechanical rolling, in most cases, the toughness characteristics of the welded joints are better compared to quenched and tempered steel. However, some brittle parts are also identified in the weld or in the heat-affected zone, but in total, the absorbed energy is generally higher, and the TMCP high-strength steel welded joints are more ductile compared to the quenched and tempered grade of the same category. Here you can see also the fractography analysis and the geometry of the Sharpie specimen, the fracture surface. Generally, larger amount of plastic deformation is identified in TMCP steel of the same strength category. So finally, in the last slides of my presentation, I would like to summarize the main conclusion of the challenges and possibilities of the welding of high-strength steels. As we could see, there is a strong relation between the steel processing route, weldability, and the recommended welding technology. DMC P-roll steels seems to be less sensitive to welding heat input in terms of the deterioration of mechanical properties in the heat-affected zone compared to quenched and tempered steel. Heat-affected zone brittleness cannot be avoided in quenched and tempered steel. Its extension should be minimized. And within GMEW process, advanced boost technologies can be very useful for the welding of high-strength steels, especially with low heat input, and the application of beam welding technologies can be advantageous. On the one hand, due to the minimized area of the weld and the heat-affected zone, and on the other hand, due to the localized post-weld heat treatment can be performed by the same heat source as the welding. Here you can see some references of our work about the welding and materials testing of different kind of high-strength steel grades. And thank you very much for your kind attention.
Thank you so much, sir, for this wonderful lecture. I hope this will be very informative for many of the people here who are watching this. Thank you so much.
Thank you very much.
Sir, hello sir.
The remaining participants who want to give their lecture, please move to the F2 auditorium. What?
Wait.
Please wait, please wait.
Sorry, please visit it. वो पेन टाइप कुछ है यहाँ पे चालू 251 पेपर आईडी
Audio. Please continue.
On development of mathematical model to predict angular distortion in FCA welded stainless steel 301 plates. Throughout the paper presentation, throughout the work on the paper, we have went through literature survey, material selection, selection of welding parameters, experimentation, measure of angular distortion, results and discussions, and then conclusion. Flux core arc welding. During the process of flux core arc welding, a continuous wire-fed electrode is fed on the base material through a spool. A constant voltage welding power supply is maintained. This method can be automatic, semi-automatic, or it can even use a robotic arm. In this process, we usually use a shielding gas to prevent the weld from oxidation. So coming to angular distortion, when we weld a plate or any base material, the point where the welding is taking place has a high heat. but at the ends of the plate, the heat concentration is low, thereby making a heat gradient, and when the heat is cooling down, so the cooling rate differs because of the heat gradient, and which makes the contraction at the center more than at the corner of the plate, which leads to angular distortion. Angular distortion is very catastrophic, as if we do not treat this angular distortion, we can lead to high stresses in the pressure vessels or any steel that we are using even in automobile sector. We have selected stainless steel 301, which is austenitic, because it has good ductility, high strength, and it is highly used in industries for making pressure vessels and automobiles. For the filler material, we have used 308L filler material of diameter 1.2 mm. We selected the following parameters. We worked on these parameters, adjusted the range, and obtained the results ahead. This was the welding setup that we used. Here we can see the power supply. The carriage was mechanized. We used the filler wire spool, as you can see over there, and a CO2 gas cylinder that we have used as shielding gas. After we have welded the plates and obtained the new welded plates, we measured the angular distortion using a vernier gauge, surface table, and weights. Now I would like to call Aryan to go ahead.
Hello everyone, my name is Aryan Agarwal and I am from Netaji Subhash University of Technology, and I am the co-author with Drishti Adlakha under the supervision of our teacher Dr. Pradeep Khanna. So coming to our next session, this is the design matrix, and the design matrix was created using a design of experiments technique, and the software used was the software which we use here was DOE. And this is the design matrix. As you can see, there are different parameters. We took 5 different parameters. This is the mathematical equation which in this slide, we input the measured angular distortion, and from those values, a mathematical equation was generated, and this is the mathematical equation which was generated by the software. These are the results. As you can see, our efficiency is 84.55%, which is significantly high. We use ANOVA, which is known as analysis of variance, to check the adequacy of this model. And after the results, we plotted the graph to check the significance of these results. So from the graph, it is pretty clear that by increasing the wire feed rate, the angular distortion decreases, which is in our favor only. And by increasing the voltage, the angular distortion is also increasing. And the reason is quite clear, because if the voltage increases, the heat gradient also increases. And by more heat gradient, the angular distortion automatically increases. By increasing the welding speed, the angular distortion was decreasing, and by increasing the nozzle to plate distance, that is the arc distance, the angular distortion was significantly decreasing. And by the direct effect of torch angle, we can see a slight increase and then a dip in the angular distortion. After the single factors, we took 2 factors at a single time to get a relation between them. So I would like to ask Drishti to explain these plots.
Okay, so as we have seen in the previous graphs, like for nozzle and plate distance and voltage, here we are seeing the combined effects when we consider nozzle to plate distance and voltage all together. So what would be the effect on angular distortion? So as you increase the voltage and increase the nozzle to plate distance both simultaneously, the angular distortion would also increase. Coming to the next, torch angle and welding speed. In this, if we decrease the welding speed and increase the torch angle till certain point, the angular distortion will increase, and after that, even if we increase the welding speed and increase the torch angle, the angular distortion will fall. Conclusion was pretty simple that when we used CCRT technique, central composite rotatable design, which proved to be very helpful while we were developing the mathematical model to predict the angular distortions when we have our given input variables. Input variables were welding speed, voltage, nozzle to plate distance, torch angle, and wire feed rate. When we increase torch angle, welding speed, and nozzle to plate distance, the angular distortion was was having an inverse relation. And on the other hand, there was an increment on angular distortion with the increase in wire feed rate and voltage. The optimized results are shown here. The least angular distortion was obtained at the following input parameters. These were the references, and we are open to questions. Thank you.
Any questions from audience?
Okay, go to your equation of mathematical equation.
Yes, sir.
How did you get this?
Sir, so as we used DOE software, design of expert, in that we had put all the input variables and our angular distortion readings that we got, and we said that that we want angular distortion to be minimum. So
you know the significance of A square and C and all these things?
So, sir, in this mathematical equation, you can see that our input parameters are the variables here. Like A, B, C, D, E represents our wire feed rate, voltage, welding speed, NPD, and torch angle. So, in this mathematical equation, what it says that at A square and B square, like if the let's suppose that B square values shows a significant increase in the angular distortion. That means that voltage is a major factor which is basically dominating the angular distortion. So there is a direct connection in voltage and angular distortion. By analyzing this mathematical equation, we came to our conclusions and those graphs. And from our research work, we concluded that there is a significant direct relation between voltage and angular distortion.
also, sir, I would like to add, like whenever on the industrial level, we cannot ignore the angular distortion. So what we can do is we can put in the input variables whatever we are thinking, like for example, voltage 16 volts and wire feed rate so and so values. We can put the values and get the angular distortion.
Have you checked the nature of this mathematical model? Sorry? Which type nature of this matter, whether it is a linear or non-linear?
Yes, we checked it on using analysis of variance, and these are the results. It was a linear model. When we were making the model, it was a linear model.
How come?
So because there was this point in the software where
Oh, sorry. You are saying about that. It is a quadratic model because there is A square, CE, CD, BE, and this is a quadratic model only. I got confused in that. Since this is
Make sure that if you are dealing with mathematical equation, you have to know the basic fundamental that what type of equation it is.
It is a quadratic model.
Whether it is a quadratic or simple.
That's
or
why there are
partial.
only two-phase interaction only, because if there had been a cubic model, there would have been graphs with three-phase interaction. But we restricted our study to only linear and quadratic study only, so that's why we made a quadratic model.
Have you compared your this result obtained from this mathematical model with any published research work? Published research work. Similar type of work has already been documented, whether in form of experimentation, not in this form, but using this model. Have you checked the how much variation it is there in that result?
Okay, so before developing this mathematical model, we did a literature survey, and in that literature survey, we saw that many of these type of mathematical models, which are for different materials, They are generally quadratic and they have a significant value of r square greater than 80 around.
Have you introduced any comparative study related to results in your work?
No.
Okay. You can enrich your work by adding this, and it's most important part, because whatever in the scientific community, whatever we were delivering, it should have a significant relevance, and the significant relevance come from the validation or comparison of our work with the other. Once it get validated, then it's named by your work. Okay. Okay. Thank you.
Thank you so much.
Thank you so much, Drishti and Aryan. So I would like to call paper ID 154 and 153, Dr. Sachin Mahakalkar. Please come on the stage.
You have given in same PPT?
No, this is 154 now, or 153 is different paper.
Have you given it to him?
But it is in separate folder.
Okay, alright, this is good. So it's here, and you can change that.
150.
It's 153.
The next one. I do 154.
Same only.
Good evening, sir. My paper title or paper ID 154, determination of critical parameters to improve the productivity using statistical mathematical models for a corrugated sheet box production process industry. All of you are aware of the corrugated sheet boxes. It's one of the very important product which the industry requires. The fragile components normally are transferred through this corrugated manufacturing process. So this corrugated boxes, if you have seen in our region, in almost all part of the India, you find that this comes under the small scale industry. And everywhere you come across that, it is seen that there are the man-machine systems which has been used in these industries. And nowadays, because of the transporting cost, these type of industries are they normally set up side by to the industry so that you can reduce the transportation and directly you can send the corrugated boxes to the industries. The introduction part, that is the corrugated scenario in the Vidarbha region. So we have come across many industries where we have seen the similar type of man-machine system. There are various machining processes like the making of a corrugated sheet, and then we have the folding or the slotting machine is there, then there is a gluing machine, then there is a stitching machine, and that's how the boxes are made. So if you overall take a case study of that, you find that there are so many parameters or so many input parameters which if we can minutely observe and if they are improved, then naturally the productivity of the product can be improved. So the manufacturing process include all these machining process which I have talked about. Then the identification of the parameters. The corrugated box sheet, all of you have seen, it is made up of a 80 GSM paper, which is normally purchased from the Ballarpur paper industries. And these papers, depending upon what weight you want to carry inside the box, that will depend upon whether you have to have a 3-ply box, 5-ply box, and then you can also have a stacking type of, for example, if you are transferring the bottles or any other components inside these corrugated boxes. So then the identification of the parameters was very important, and then we have considered many parameters, like the ergonomic parameters were thought of, the machine specifications were thought of, because every machine was operated by the human operators. Then also the weight of the operators, and yes, yeah, yeah, yeah. So in all, we have considered 43 parameters inside that corrugated manufacturing industries. Once the parameters were introduced, our main objective was to find out some of the critical parameters which can be concentrated so that you can increase the productivity of the industry. So for that, we have decided to carry out the sensitivity analysis and find out some dominating parameters among the 43 parameters. So that was our main objective of this research. So we have gone through many research literatures wherein the mathematical model, some of them they have used the regression model, some of them they have used the dimensional model. The response surface models were also, and some of them they have validated with through the ANN model also. So we have formulated these 43 input variables, and then the output was thought that what should be the output, and how the output we have considered, because every machine was operated through the machine operators, the human beings. So we have decided as the that is the human pulse as the output, and we have taken the pulse energy at the starting of the shift, and similarly we have also taken the data of the pulse energy at the end of the shift, and then this human energy was one of our output parameters, and then a model was set up with respect to the 43 independent and the one of the this with respect to the human energy as the output variable. Now once the model was set up, and then then we have studied the models, and the models once studied, we have seen some of the, out of these 43 parameters, we have found out some of the, because we always want that a human energy to be minimum used in while working through the shift. So that minimization were our main focus. So we have seen some of the 13 or 14 parameters from every model, the regression model, the dimensional model. And then out of this 13, 14 input parameters, then we have decided to find out some of the critical parameters of these. So then we have that is use the sensitivity analysis, that is by using the MS solver as one of the technique, and by using the partial derivatives, we have taken these 13 parameters, and every parameters were added plus 10 minus 10%, and then we have seen the effect of these parameters on the output, that is the human energy. And from that, like the MS solver, it gives us the tornado sensitivity chart, and in the form of a descending order, you get the critical parameters at the top, and then the that's how we have identified out of these 43 parameters, like yeah, I haven't shown, but then I can show you on the, I have a paper, because there was a limitation of the, but directly you are going to the, yes. But you should include the model and the calculation. Actually, sir, model was not really, it was the sensitivity analysis which was the main focus of this research. But in the presentation, yeah, yeah. It should be included. Yeah. Presentation generally. It's surprising. Actually, it looks like that because there was a limitation that it was given that six slides were there. So, okay. Yeah, yeah. I was waiting for your model to come. Okay. I was waiting for your charts to come. But again, the result part, this is only the conclusion. There is no. And then the critical. You are talking about solver, and again you are talking about ANM. You are talking about so many things. You are talking about so many parameters, 43, and then. Before any making presentation, it is very necessary to include all these results. No, again, I'm telling. So, yeah, that is actually everything has been in the paper, but then because of the limitation of the slide, yeah. No, no, but then at least we have a bond with us that every paper normally it is given. Yeah, yeah, no problem. I accept your suggestion. Only I thought that it was a limitation instead of putting 20, 25 slides. Yeah. Yeah, yeah. Thank you.
Good afternoon, all of you. Myself Neeraj Suneria, and I am presenting on the behalf of Dr. Sachin Mahakalkar sir, and the paper title is Buckling Analysis of Piston Rod for Hydraulic Cylinder of Cotton Bale Press Machine. Here are the contents.
The similar type of presentation you are having just like that?
No, no, sir. Sir, results are there. Yes.
Your paper ID is 153.
153.
Speak loudly, please.
Yes, sir. So cotton bales are actually generally made up of finely processed cotton, and basically these cotton bales are useful in various industries like bed sheets or garments or in the medical industries. These bales are pressed with a machine having a cylinder and a ram. That cylinder is generally called as tramper cylinder, and the normal weight of cotton bale is around 170 kgs, and it consumes approx 17 cubic meter space when it is not compressed. So it is required to be compressed in a small blocks. The work is focuses on the buckling analysis of the rod which is used in this cylinder, which having the dimension of 2627 mm, and the diameter is 70 mm. So it is a long column which having the slenderness ratio of 154. So the buckling will be the main consideration while analyzing this type of rods. So we have checked the buckling of this rod with the experimental method, and we have calculated the buckling with the mathematical equations and also with the help of ANSYS software. Here are the literature survey. Many of the authors have done similar kind of work for different applications, and many of the authors found out that the buckling is also one of the most important factor while considering the design of such types of rods. And some of the authors also modified the the composition of the material and also the type of metal used from mild steel to the hybrid aluminum, which is attached with the different carbon fibers. Here the methodology in which we have done, we have selected different input parameters and find out the different output parameters with the help of two type of analysis. One is the mathematical analysis and another is numerical analysis. Also this experimental work is done in the industry. I have used the Euler's equations for the long columns, that is PC is equal to pi square EI by LE square, in which PC is the crippling load, E is the modulus of elasticity or Young's modulus, I is the moment of inertia, and L is the effective length of the member. Here it is 2627 mm. I have made a CAD model in the CATIA software, and I have used the ANSYS workbench for the boundary conditions, meshing, and for the solving different equations. Here are the properties of the material used. The 210 GPa is the modulus of elasticity, 0.3 is the Poisson's ratio, and density of the material is 7,860 kg per meter cube. And the different boundary conditions are in the Y and Z direction, the load is not applied, and the rotational displacement is also constant in the Y and Z axis. The main the axis to be considered is the x-axis, where the linear and angular displacement will be there. Here are the results in while calculating the results in the ANSYS software. 3 modes were selected, in which we have first in the mathematical model we have used a normal rod without any curvatures, without any grooves, and in the ANSYS model we have introduced some grooves to reduce the stress concentration, which will prevent the buckling of this type of rod. So we have selected 3 modes to improve the accuracy of the model. And in the first mode, the maximum deflections come out to be 1.003 mm, and another 2 models, when the load amplifier is increased from 7.12 to the 7.13 and 7.17, the maximum deflection comes to be 1 mm. But in the mathematical model, this factor of safety comes to be 2.30. But in this model, the maximum deflection find out to be 1.003 mm at the 7.12 load multiplier, which is the direct measure of factor of safety. So we can use this type of, we can do with this type of changes in the piston rods to reduce the stress concentration, as well as to reduce the total buckling and the to reduce the maximum deflections. Here are the conclusions. Analysis of current design of piston rod, both mathematically and by finite element analysis, has been done in this work. In the mathematical analysis, the rod is operating with the factor of safety of 2.3, but in the FE analysis, the factor of safety comes out to be 7.12, which is the least in all the 3 modes, which has to be taken. Still, with these results, during the practical applications, it has been a slight tendency to buckle. So other methods can also be implemented, like induction hardening or precipitation hardening can be used here to reduce the total buckling of the piston rods. Sir, unstructured mesh. Unstructured mesh. Yes, sir. No, 2.3 it is coming. Yes, sir, after the modified design. So it is after the modified design, and 2.3 is for the plain rod. It is around the same. It is same.
Have you added that comparison of that mathematical model?
No, sir.
In the same?
No, sir. I have not added the that ANSYS simulation for that same rod, but I have added the.
Because here there is no word mentioned in the conclusion modification, whatever you are saying. It is simply showing that in mathematical analysis, it found that the rod is operating with the factor of safety with 2, whereas the final element analysis, the factor of safety turn out to be 7.1. So, if you are going to compare this 2 with 7.1, the range is more than 100% around. Percent variation, this type of result will not going to be acceptable, because that it should be in the range of plus minus something, hardly with, if you are comparing your result with the computational work,
Yes, sir.
hardly it will going to be 10 to 15% or max to max 25%. Rather than it will not going to accept. If you are going to compare, it's plus more than 100 or 200%.
It is about to 200.
But it is not going to be acceptable. If here you are stating that it is a modified version, then
Yes,
you have to mention that it should be a modified one. Here no word it is there. So therefore it will going to be very contradictory for you and as well as for your research, that whether you have performed or not. Okay.
Yes, sir.
From our side, just mention that whatever you are saying modification here, and make a table that whenever you are stating your any work related to computational work, you have to make on one table at least, that this result we are getting from mathematical model and this one with the computation. So that comparison is made, so that there is little transparency. But if one more thing you can include in that, comparison of that your work with any published work. Over that you can mention.
Yes, sir.
Yeah. So there are two type of validation we can make from own mathematical model or around from published work. So just incorporate that part. This is suggestions from our end. Okay. Okay, sir.
Thank you.
Thank you.
Okay.
Thank you so much, sir.
Thank you, sir.
So I would now like to invite paper ID 288, Ms. Falguni Gorana on the stage.
Good evening, everyone. So the topic of my paper is parameter optimization for dimensional accuracy of fuse deposition modeling using Taguchi method. The name of the authors are myself and Mr. Kiran Kumar Sahu and Dr. Yashwant Kumar Modi. So I am a research scholar from JP University of Engineering and Technology, Guna, Madhya Pradesh. Moving to the first slide, these are the contents. So I hope everyone knows what is additive manufacturing. It is also known as 3D printing. So this is the process which is followed by any of the machine. Now, fuse deposition modeling is a process which comes under the additive manufacturing technique, and it was first developed by Scott Cramp in 1988, and it was got patent on 1992. And the material which is used here is a thermoplastic polymer, which is in a wire form, which is used in a wire form. And with the help of this extrusion head, it is heated up and deposited on the bed. So here is a small introduction of Taguchi and the method which we have used here. So Genichi Taguchi was an engineer who proposed a robust method for optimizing process or product. So he suggested that for an experimental design, there should be a fractional factorial method rather than the full factorial. We should opt. He also defined that loss function which we have to calculate is between the deviation between the experimental and the desired values. And this loss function is transformed in the signal to noise ratio, which we will see in coming slides. So Taguchi categorized the performance characteristics in three category, that is smaller the better, larger the better, and nominal the best. Here we have used the nominal the best, and this is the formula which we have used here. So this is our literature review. In this we have found that some of the researchers have revealed that the parameters, the process parameters to improve the performance characteristics should be optimized for a fabricated part. Again, we have seen that the Taguchi method is a simple and economical method, procedure. So that's why we have used it for dimensional accuracy. And also, we can get the Taguchi design to optimize the process parameters and the output responses. Output responses may be dimensional tolerance, surface roughness, build time, etc. So here the quality of the part mainly depends on the material which we use and the machine, the parameters inbuilt in the machine.
What are the parameters?
Sir, they may be the layer thickness, they may be the
No, at least which are the standard parameters? Standard parameters, because here in that fused filament process.
So we have taken the parameters.
Okay, just go to the slide.
In the next slide. So this is the problem formulation. In this we are going to achieve the optimum levels of process parameters for best possible dimension accuracy by Taguchi design of experiment approach. So here we have used Taguchi's orthogonal array and we have find the significant parameters that with the help of signal to noise ratio analysis, and we also have evaluated the percentage contribution of the parameters with the help of analysis of variance. So this is the description of the raw material, the machine which we have used, and the process parameters which we have taken in the consideration, and the response parameters, that is length and diameter, because we are discussing on the dimensional accuracy. So here we have chosen the linear dimension and the circular dimension. So these are the parameters, and there are the levels on which we are going to check the significance of these parameters. So if we choose the full factorial design, then we have to perform experiments. There are 81 experiments we have to perform, but with the help of orthogonal array, we got this reduced to 9 experiments, and we have taken repetition because for the length and for the diameter, that's why it is 18 in number. So these are the 9 experimental runs for different parameters. We have taken 9 experiments, but these 9 experiments will give us the whole information of the significance of the parameter. So this is the part. These are the signal to noise ratio which we have got with the help of that formula. And this is the result and discussion. Here we can see in the graph the points which are significant, optimum values of different parameters we can see in the graphs. This is for the length and this is for the diameter. So here we have found that for the length, as we can see in the pie chart, build orientation is a significant parameter which plays a significant role in the dimensional accuracy of the part for particular length, linear dimension. And for circular dimension, the layer thickness plays a significant role. This we have evaluated by analysis of variance. So we have concluded that with signal to noise ratio, we have analyzed that the table which I have shown, with the help of that we got the significant optimum values of the parameters and their levels. So with the help of that we can get a good dimensional accuracy. With ANOVA, we have found that build orientation contributes more in linear dimension, and layer thickness contributes more in circular dimensions. And Taguchi approach is a simple approach, but we have chosen this approach because we can use it in the single response parameter for optimizing parameters, the single response parameters. And if we have to go on the multiple response parameters, we have to optimize the multiple response parameters, then we can switch to any other method. It may be gray relational analysis, RSM or ANN, we can choose that also. So these are the references. Thank you.
Thank you, ma'am. It was nice presentation. I have only one fundamental questions.
Yes.
That what is the significance of temperature and pressure in fused filament process?
Sir, it also has a significant factor because...
No, I'm just want to know about the impact of temperature and pressure on the finished product, or which type of heating generally used over here in fused filament process. With basic mechanism, I just want to know.
Sir, right now I will not be able to answer that.
Okay, ma'am. Okay. Thank you.
Thank you, sir.
Thank you so much, ma'am. So now I would like to invite paper ID 395 on the stage, Ankush Maurya and Arshit Nanda.
Good evening, everyone. My name is Ankush Maurya from Department of Mechanical Engineering, Manavachara International Institute of Research and Studies. The topic of our study is an explanatory study on process parameters of injection molding process. These are the outlines which we will be going through. Introduction. First of all, what are the plastics? Plastics are the polymers which is nothing but the repetition of the monomers. Monomers and the plastic are generally divided into two major categories. First is thermoplastic and second is
Actually, let's need a study.
Your paper ID?
Sir, it is a study paper.
Your paper ID?
Sir, 395.
395.
Yes, sir. So these are the process parameters in injection molding machine, which are which is applied in a controlled manner for the manufacturing the component. Yes, sir.
You have read some research papers also regarding that?
Yes, sir.
Okay, which year's research paper you have considered for this study?
So from 1970 to 2019.
1970 to 2019.
Yes, sir.
Okay, so almost around 20 papers you read?
Sir, 48.
You have gone through 48 papers you have gone through?
Yes, sir.
You have done? You read all, understood?
Sir, we have
some issues with the methods used in there. They were
Yeah,
not all clear.
I agree. If you have solved 48 papers, you must be.
Sir, we have studied lots of parameters and defects in the
Okay, then tell me what is the conclusion you found that from this to this means the era you I think almost have done 10 to 15 years papers. So what is basically evolution means from the basic you read something and then in the last initial stage in 2019. So what you got the difference? Anything you have done?
In form of problem.
Yeah.
So gap.
Anything.
This thing which is not been explored.
We don't want theory definitions, na? It's okay. What we means, what is the purpose of that? कुछ एक आध slide है वही explain करो. Getting our question समझ में आ गया? हाँ तो research gap.
Existing problem है उसको solve करने के लिए आपने approach किया है.
क्या किया?
ये चीज़
ये definition theory figures I think this is not research. Okay, जो आपने 48 पेपर रीड किए हैं जो सर भी बोल रहे हैं कि we want to know क्या मिला आपको मिला क्या?
So for the earlier papers, there were basically three methods, like
Yes.
response surface methods and Taguchi method and the ANOVA method. And towards the 20th century, 21st century, 2019 and before that, they were using artificial neural network methods and also different cooling channel designs. For example, spiral cooling, helical cooling, and octagonal cooling designs. So we actually just read them. We haven't written it down on this presentation. Yeah. So it's not like.
Here you are showing the defects of the. Have you
Yeah.
tried to reduce this defect or minimize this defect in your
Not
work?
yet, sir. We'll work on that. We'll work on that in the next phase of our project.
Okay. Yeah. This is the comprehensive work. Yeah.
This is just the study.
A study.
Yeah.
Okay. Okay. A study only. Okay then. Or which can be.
Not in this slide, no. Not in this PPT.
Okay, just explain this part. Previous one. Yeah. This part.
We've just mentioned what processes we have read about, like Taguchi and all. So we've just written that the process parameters are very important, like to reduce short and other defects and all.
So in which area we can explore if we are going to consider this type of work? Can you enlighten that part?
Sorry, sir? In what?
जैसे आपने इतने सारे पेपर पढ़े हैं, ठीक है, कौन सा एरिया है जिसमें अब अभी काम करने की जरूरत है?
Injection molding, yeah.
Optimization
So
में
if you even see
क्या
even
दिक्कत
today,
क्या आ रही है
if you
optimization
see,
में?
like you know Neelkant from they make chairs, right? The first few chairs that they make, like 50 chairs that they make, have some defects in them.
Okay.
Yeah. So by the time that heats up and that all, then they get the like flow going, like one after another.
Yeah. The first 40 chairs get rejected due to they are having that reject.
Yeah.
So that part needs to be minimized.
That is thermoset
right?
material that goes to waste.
Yeah. Okay. That's the main problem. And any idea how you are going to minimize that part, that defects
Yeah,
part?
so, different cooling channel designs and different injection molding pressures and different cycle times and all.
Set of times. Based on that initial 40 designs, that product outcomes can be minimized, so that ultimately the production can be enhanced. Yeah, very good.
Also less
That part we just want to know that this work can be further been extended That this is the gap which we have identified from this research paper.
Yes, sir.
So that is the main thing we are expecting. So this is very good. Okay. Okay. Good.
Thank you so much. I would like to make an announcement for all the presenters who have already presented. Please move to the F2 auditorium for the cultural program. And I would like to call the last paper ID of this session, 48 and 248, Mr. Rhythm Joshi. Please come on the stage. Yeah, and I would need your paper as well as a copy. This is the one?
Paper 48 and 248. There is this PPT. Yeah.
You can play it.
You can open the both. I'll switch it.
Okay, all right.
Side by side, open that. The others. Hello everyone. I guess I'm audible and my presentation is visible. So my paper ID is 48, name of the authors Dr. Ravindra Kumar and myself Rhythm Joshi. So my title of my paper is Fortifying the Human Resources in Indian SMEs in COVID era. Yes, I'll go for the next. So these are the contents of my paper. Introduction, literature review, problem formulation, methodology, results and discussions, conclusion and references. So basically, introduction includes sustainable manufacturing, sustainable manufacturing, creating sustainable products. Basically, reducing the impact onto the nature with the help of our manufacturing practices. Okay, I'll be quick with the process. So in my literature review, I read around more than 40 papers including the time of 2022, including the time 2021. So during all that time, I compared some old and latest factors of sustainability in the meanwhile. So these are the factors of social sustainability that I found. And why social sustainability? Because during the COVID time or post-COVID time, society has been the most affected one. So if any society is affected, and if we tend to improve the social sustainability, economic and environmental sustainability can be improved accordingly hand in hand. So here I took four main social aspects, which is employee, society, customer, and business practices, which having the further primary factors such as employment, work conditions, human resource developments, let's say healthcare services what are provided, and fair trading is there, investments, job creations, and on to the basis of that we had sub factors and we prepared a questionnaire. So, for example, let's say employees. I have a question. I have a question that how many number of employees you had before the COVID time and post the COVID time, and for any other factor, let's say skill update.
Okay, how many inputs you got as a questionnaire आपने भरवाया होगा?
Yeah.
So कितने लोगों से भरवाया?
I went for 25 different industries in different sectors, including
25?
Yes, sir.
Is the number?
Yes, sir.
That is sufficient for the decision?
So actually, it's a basic start for a bigger change. So 25 industries at a start is a very good reference according to it, so I can get the idea to it. So in my next paper, I have used fuzzy D metal for understanding of quantitative and qualitative analysis. So this is the base paper for my next methodology. I'll be quick onto the slides. Yes, sir. So then I had these two research questions. What are the aspects, primary and sub factors, and what is the sustainable index of every major industry? So in my methodology, I created a question. I found out all the sub factors with the help of literature review. I put up a questionnaire with industry and academic experts, and I surveyed it, and I calculated the index of social sustainability. So these are the results of my social sustainability. Let's say if I go for then I went for the sectors of different industries. Let's say utilities and services. I only had one industry in it, the first one.
Okay, which method you apply to get the results?
So basically, it's a method. It's a process where we have the target and their existing social sustainability or their target social sustainability. According to that, we find out their mean and then we calculate it.
Yeah, that's why I'm a mean
Yes.
only.
So actually, their existing social sustainability is there, and then there is their target social sustainability. So we divide and we calculate the percentage. So here are the percentages according to it. Now let's say everyone might be like you might be questioning that. Let's say utilities and services. I have four major aspects here: 9.24, 5.5, 4.54, 5.64, and 1.16. That doesn't conclude to 100. Then I would say that
you are a research scholar, a PhD scholar.
Yeah.
You are a B.Tech.
Yes, sir. Yes, sir. B.Tech mechanical student, sir.
That's okay. Then it's okay.
Yes, sir. So let's say now the total that doesn't becomes 100. So there are other factors such as economical and environmental factors which are covered by other people. But yeah, I am focusing on to the social sustainability. So my conclusion is that through 25% to 300% efforts towards the social employment aspects that is needed to solve, especially in manufacturing, construction, retails. But in healthcare, at least 17 to 20% of business policies and practices should be changed, so their social sustainability can be improved. Yeah, so this is the basic conclusion what I said. I'll just go for the other paper.
Okay, that is second paper is yours only.
Yes, sir.
Back to back two papers.
So this is my second paper.
So you extended this work for the fuzzy
D-metal method, sir.
What is this fuzzy D-metal approach?
Yes, sir, I'll reach out to that. Can I just go with the flow? Then it will be more understandable.
No, we understood the previous one paper. This is the extension.
Then I'll go to that slide, sir.
Okay.
So fuzzy D-metal methodology basically says that here we create a relationship matrix. In here onto those factors I identified 12 enablers of social sustainability. Then we create a relationship matrix between those enablers onto for their effect on each other. So there is an n cross n matrix which is created. Then a fuzzy logic is put, a triangular fuzzy logic. It's mentioned here. A fuzzy triangular logic is put. Let's say if I have a value from 0 to 4 in my questionnaire or in my relationship matrix, the fuzzy scale puts the 0 as 0, 0 and 0.25. Let's say 2, then it goes for 1.75, 2 and 2.25. Let's say 4, then it goes for 3.75, 3.75 and 4. So it basically creates a more accurate and mean result to me onto each of the on the effect of each enabler onto their each other. Right, I'll go ahead. So this was a cause and effect diagram. The fuzzy D-metal method also gives us the cause and effect diagram. So what is causal variable and what is effect variable here? Causal variable are the variables which we can't control, and because of which our effect variables have got affected. So causal variables are the variables such as top management policies, government policies, uncertainty of pandemic, or these cultural
on which
traditions.
Parameter you applied triangular fuzzy?
What, sir?
Triangular fuzzy method you have applied.
Yes, sir.
On which parameter?
So onto the relationship matrix, I had this fuzzy D-metal method, although it's a very long process. So in the fuzzy D-metal method, it's a basically decision-making trial and evaluation laboratory.
You're using words so many, but where is the decision matrix?
So actually, I can't show it here. It's very big, so I could not fit in PPT.
How much big is this? More than
I'll show you,
screen?
Sir. I have it in my paper, sir. Wait, I'll just show it.
In terms of by.
What, sir?
rows and column, how much?
That's
Sir, actually, it is a 12 cross 12 matrix, but each of the values have around around 3 values in each of their like this. Sir, there are 4 more further
I want to
detailed.
see that formula actually. That's why I wanted to see
Yes,
the
sir, no issue,
plotting
sir.
of
You can
direct.
see.
Can you explain this?
Yes, sir, definitely, sir. So basically, it shows us the whatever the I and J quantities are there. It is from this relationship matrix here. Wait, laptop. So this. So I generated it on Excel. I was not able to find any fuzzy demetal tool to solve this matrix, so I generated it on the basis of the formula on Excel. Yes, sir. We can. So Excel app basically gives us ways. On Excel, we can put up the formulas. Let's say if I have to.
But how it loop is there?
Yes, sir. Actually, all the formulas and loops are there on Excel. Normal Excel, MS Basic Excel.
Can you do the programming?
So I can. I have done basic. I have.
Where? Okay, which tool you have used?
So I have used normal basic Excel here.
Excel में कहाँ पर जाकर ये आपने किया?
So let's say on the Excel we go to formulas. Then there are many options. So on the basis of this formula here. On the basis of this formula here, plotting of direct relationship matrix, I have used these values. We can, so basically here we have is I, J values, right? On Excel we have B7, B8, so we can directly put up as B8, B7 on, we can use that value into the other box as formula. So, and eventually Excel also gives us Excel also gives us a
Okay, good, very good.
yes, sir. So should I conclude my PPT? So according to my results and discussion, according to my results, so these are the top management policies, government policies, uncertainty of pandemic, cultural traditions and factors. These are the causal variables which we can't control for any industry. But there are other factors such as fair trading, research and development, fulfillment of customer standards, health, safety and security standards. These kind of factors we can control, so we can eventually improve our social sustainability in the post-COVID era time in our latest in industries, sir. Yes. Wait, I'll just. Yeah. This is the conclusion. So let's say if any industry is there, and if we are trying to set up any industry in the post-COVID era time, these are the factors which are there. Yeah, while they are setting, or if any industry which has had very much loss in this time, so they can focus on to these effect variables, and then they can improve them, so their sustainability will get better and their productivity will get better. But these are the variables which nobody can control, so they can avoid it and relate it, avoid.
Any work quality done in that, because it is sometimes in case of questionnaire, so forced input we get means.
I understand, so the people.
We send the form, form करके वापस भेज दो.
So so I had a trick for it. I went to the industries by my own self. I gave them the form. I also gave them an offer that if they fill my form correctly, then I'll tell them some ways by which their productivity can get increased. So I went for the survey of all those industries, and I focused on value engineering small problems. Let's say some industry have a problem of pneumatic cylinders, some industries have some problem of materials, some industries have problems of waste management. So I went for different industries. Let's say there was this mask making industry which had almost 60% of their material getting wasted because a mask is cut and the rest of the materials gets wasted. So we went for there is this startup in Bangalore for Brick 2.0. We went for that, and we gave them the waste material for the mask, and they make the bricks out of it. I don't know the process of it, but yeah, I helped them so they can fill my questionnaire in a correct way.
Good.
It was a two-way process, not a one-way process, so it is not forced, sir.
It is is a very important pre-examination tool you are delivering to the industry, which have a great significance over here.
Yes, sir.
Because generally, whosoever going to establish any industry, I don't am so sure that they are going, but these are the essential things they have to keep in
Sir,
mind.
right now
Even
I'm
in the food industries also, just like the whatever a bada pav wala is also going to establish it all. But some factors he needs to be
Sir, I
work out.
took basically
So,
small and medium
yeah,
enterprises
I
here.
we understood. Yeah, very
So
interesting.
basically, I want to be an industrialist in the future,
No,
upcoming
very
future.
good.
So
We are
this was very
expecting that.
important to me
Yeah.
that I have
Even
to
you
calculate.
can give your service as a freelancer
As
to the
my
industries
own.
also in enhancing their productivity.
Yes, I
By
right
using
now.
that mathematical modeling or just like that, these are the things which you need to be focused.
Yes, sir.
Yeah, that's a good one. Very good.
Thank you so much, sir.
Okay.
Thank you so much, Mr. Rhythm.
एंटरप्रेन्योर के लेवल पे हिसाब से ये बहुत अच्छा वर्क है, मतलब एप्रिशिएबल वर्क है कि मतलब इस डायरेक्शन में टेक्निकली बहुत कम लोग सोचते हैं कि हाँ मशीन बना दिए क्या है, पर वो फेलियर पॉइंट ऑफ व्यू से अगर देखा जाए, मतलब मशीन ब्रेकडाउन नहीं, हाँ सस्टेनेबिलिटी फैक्टर के हिसाब से देखा जाए तो ये वर्क बहुत अच्छा है.
I think that was the most amazing presentation for the day. So to wind up this session, I would like to request Mr. Dr. Anup Kumar Shukla to come on the stage and present the thank you memento to our session chair. Dr. Mandeep, can you please come on the stage? Thank you so much, sir. And I would also like to invite Dr. Tushar Chaudhary to come on the stage near the dais. So thank you so much for coming to this session.